In this video, we are going to discuss our topic 3 concepts to review for your quiz. Reminder, your quiz will be on Wednesday of week 10. This video is not due until Friday, but you should do it before Wednesday to review for your quiz. All right, so we have our first sample here of something that you might see on your quiz, which is evaluating with exponents. So let's take a look at here. Evaluate the following, 3 to the 4th. So if we remember, every exponent expression has a base, which tells you how many, the number you're multiplying. And our exponent, which is how many times we're multiplying. So in this case, 3 to the 4th power would be 3 times 3 times 3 times 3, which is not 12. If you add 3 repeatedly, that would be 12, but we are multiplying. If you remember, we can do this by grouping them together. This 3 times 3 would be 9. This 3 times 3 would be 9. 9 times 9 would be 81. All right, let's move on. Our next sample, prime factorization. So, I apologize. All right, so what is the prime factorization of 40? If you remember, when we're doing our prime factors, we need to break it down into a tree and find which numbers cannot be broken down anymore. So 40 could be broken down into, again, it doesn't matter where we start, but let's start with 10 times 4, because that's probably where most of your brains are going. Now 4 can be broken down into 2 times 2. Both of those are going to get a circle because you can't break them down anymore unless it was 1 times 2. But you cannot have a 1 in a factor tree. That is one of our math jail offenses. So we're going to give those a circle. 10 could be broken down into 2 times 5. Both of those would get a circle because you can't break them down anymore. So now we're going to write our numbers that got circled. I have 2 3s and I have a 5. My 2 3s would be 2 to the 3rd power because it's 2 times 2 times 2. It's repeated multiplication times 5. So that would be my prime factorization. All right, let's move on. All right, greatest common factor. So something you might see with greatest common factor, you have 20 red beads and 16 blue beads, and you want to make identical bracelets because you want all the bracelets to be the same. You can't have one bracelet with 5 red beads and another bracelet with only 3 red beads. That wouldn't be fair to your friends who you're making them for. What is the greatest number of bracelets you can make using all of the beads? All right, let's see. So we want to figure out what's the biggest number that I can divide both 16 and 20 by. 16 breaks down into 4 times 4, and each of those breaks down into 2 times 2. So 16 is 4 2s. 20 breaks down into 2 times 10. 2 gets a circle, and I'm sorry, I forgot to circle all these 2's as well. And then it breaks down into 2 times 5. So 20 would be 2 times 2 times 5. Now what I see here is that in both lists, they share not 1 2, but they share 2 2's. So they don't just share a 2, they share a 2 times 2, which would be 4. So the greatest number we can divide both beads by would be 4. All right, let's move along. Now, on the flip side of that, let's talk about least common multiple. You do laundry every 12 days, and you scrub the shower, that should say, typo. All right, you should scrub the shower every 15 days. If you do both chores today, how many days until you do both chores again? So let's start with the laundry. I'm going to count by 12s because we'll do it again in 12 days, then in 24, then in 36, then in 48, then in 60. And remember, we only really need to list our first 4 or 5. And then after that, if we can't find one, we'll keep going. Scrub the shower every 15 days. 15, 30, and then 45 up, and then I see 60. So she would do both chores on the same day again in 60 days if she keeps that pattern. All right, let's move on. All right, writing expressions. A couple of things. So remember, expressions have no equal sign. Expressions do not have an equal sign. You have $300 and spent $134 on groceries. Write an expression to show how much money you have left. All right, so let's think about the operation. As you can see, the answer is already highlighted, but let's talk about why that's the answer. First off, if we are spending money, that's going to mean to subtract because we are getting rid of the money that we had. We started with 300 and then we took away 134 after we bought the groceries. So it would be 300 minus 134. All right, let's keep going. All right, let's look at coefficients, variables, constants, and terms. So it's asking us to identify each of those things in this expression. So as it says here, the answer is already highlighted, but let's talk about why that's the answer. A coefficient is the number that goes with the variable, which in this case is 2. The x would be our variable because it is the unknown, and 5 would be our constant because it doesn't change. That is a constant term because no matter what, it's still 5. But the 2 can change depending on what x is. If x was 5, then 2x, that would become a 10. So that can change, but the 5 doesn't. Now let's talk about terms. Terms, as if we remember, are the parts, and they are separated by addition and subtraction. So in this case, we have 2 parts. We have 2x, so that's our first term. And then we have 5, which is our second term. 2x is a term that has a coefficient and a variable. 5 is a constant term with just the 5. All right, let's keep moving. All right, now let's talk about algebraic expressions, writing them. And algebraic expressions are just like numerical expressions. They do not have an equal sign, but they do have variables. So that is what is different. Algebraic expressions have variables. All right, you have X pieces of candy. You want to split them into 6 trick-or-treat bags. Write an expression to show how much candy will be in each bag. All right, so I see that word split. So I'm thinking division. We are splitting up our candy, which is X, into the number of bags, which is 6. So our expression would be X divided by 6. All right, let's keep moving. Also, actually, one more thing. Just remember, this would not be 6 divided by X. With division, order matters. All right, identify equivalent expressions. Reminder that equivalent means the same. So they look different, but they mean the same thing. In this case, Which of the following is equivalent to 3x? And as we can see, it is x plus x plus x, because multiplication, if you remember, if we spread this out, that would be 3 times x, or x times 3. And multiplication is the same as repeating addition. So 3 times x is really adding x to each other 3 times. Just like 3 times 2 would be the same as 2 plus 2 plus 2. They would both equal 6. A would not be the correct answer. That would actually be x to the third power, because exponents are repeating multiplication. Multiplication is repeating addition. Exponents are repeating multiplication. All right, let's move on. All right, our favorite, the distributive property, meaning we need to distribute toys to both of our children. An outside term can be multiplied by both terms on the inside. So 3 times 2x would actually be 6x's. If I have 2 of something and I multiply it by 3, I would have 6 of them. But I have to be fair to both of my children. So now 3 times 5 would be 15, which is why it is 6x plus 15. Don't get tricked, not the 6x plus 5. That would mean that you weren't fair to your second child and that you only multiplied the 2 by 3 and not the 5. All right, let's keep going. Last one. Simplify the following expression. So simplify really, again, just means to make it smaller, or combine what you can, make it simpler. So we need to look at our like terms. Here I have 2x. And if you remember, like terms have the same variable or the same exponent, or are just plain constants. So in this case, I can put my 2x and x together to make 3 x's. If I have 2 xylophones here and 1 xylophone here, that makes 3 xylophones. And then I'm adding together 3 plus 4 would give us 7. So that simplifies to 3x plus 7. Remember, if you, that x and 1x are the same thing. It's just one of those things. It's like writing 0.0. You don't really need to do it. It is understood. All right, so that is going to bring us to the end of our homework, or our topic 3 study guide for your quiz. Hopefully you did this before the quiz so you are prepared, and we will see you soon. All right, bye guys.